Morning, friends. So let's start with the today's Google Classroom. So today's Google Classroom, it is for the paper name, that is physical chemistry, and the paper number is 8. And the chapter we have to discuss today's in Google Classroom is that is the thermodynamics. In a previous Google Classroom, we have already discussed lots of Google Classrooms about the thermodynamics. So today we start with our next topics about the this chapter, that is thermodynamics. So today we have to discuss heat capacity, and then heat capacity is at constant volume, pressure, and their relationship. So these are the topics we have to discuss today in a Google Classroom. So before to start with today's Google Classroom, we have to know that, or we have already seen that what is meant by thermodynamics. So thermodynamics is a branch of physics that deals with heat and temperature and their relation to the energy, work, radiation, and properties of the matter. The behavior of these quantities is governed by the four laws of the thermodynamics, which convey the quantitative description using the measurable microscopic physical quantities, but may be explained in terms of the microscopic constituent by the statistical mechanics. This thermodynamic topic is applies to the wide variety of fields, that is a science and engineering, especially physical chemistry, chemical engineering, and mechanical engineering. So let's see what is meant by the heat capacity. The heat capacity, or it is also called as thermal capacity, is a physical property of the matter, defined as amount of heat to be supplied to given mass of material to produce unit change in its temperature. The SI unit of heat capacity is in joule per Kelvin. Heat capacity is an extensive property. The corresponding intensity property is specific heat capacity, dividing the heat capacity of amount of substance in moles, yields its molar heat capacity. The volumetric heat capacity measures the heat capacity per volume. Heat capacity is often referred to as thermal mass in architecture and civil engineering to the refer heat capacity of the building. What is the heat capacity? Heat capacity, it is a definition it is given, that is a quantity of heat required to raise the temperature of a system by the 1 degree. It is the amount of heat required to raise the temperature of the system by the 1 degree. So this heat capacity, it is in the equation, it is given as C is equal to delta Q upon delta T, where C is equal to heat capacity, delta Q is equal to the amount of heat absorbed by the system, and delta T, it is the rise in temperature. The units of the heat capacity are joule per Kelvin or the joule per degree centigrade. Larger the sample, greater is the heat capacity. It is simple that larger the sample. So how much sample is there? So how amount of the heat is required? Common to use specific heat capacity or the molar heat capacity. Heat capacity is for the ideal gas. So heat capacity at constant volume and the constant pressure, or CV is equal to at heat capacity at the constant volume given the equation. Then heat capacity at a constant pressure given the equation. Then molar heat capacity at a constant volume given this equation. Then molar heat capacity at constant pressure. So these are the equations. So these are the equations as given at temperature or the. So these are the equations for the heat capacities at ideal gases. Process at constant W is equal to 0. Also good news that we can use delta U is equal to C or U. So these all the equations are the given in the these Microsoft Word notes. So these all notes are the share with you. If you have the any problem with this topic, you can share with me in the comment section. Thank you.